Okay, this is a guide on how to set up the Micromanager variant of the Triggerscope firmware. I have a Triggerscope set up. This is an unboxed one. I don't have a case in it, but I'm going to follow the directions that you can find on my website on the product page, which is the Getting Started guide for the Triggerscope 4. So to start off with, we need to download and install the drivers for the Triggerscope. So if we scroll down a bit, you'll find there's a description of the two firmware options. We'll go and grab this a little bit later. We'll keep scrolling down to driver installation. And so we'll follow these directions. I'm just going to do this using the guide and giving you some examples of key things. So if we use this link, it will take us to the Arduino IDE install, which is a variant of Arduino, and we'll choose whichever installer you need for your operating system. I'm going to be using Windows 10 x64 as the demo here. Once that's downloaded, we'll run the installation. It's going to ask you to install some drivers. Go ahead and do that, and when complete, we'll go grab the Micromanager firmware. So one of the ways to know that our driver is working and that our installation for the software has been complete is if I right-click down here on the Windows Start button. So I right-click and I choose Device Manager. What I want to see is at least one entry under Ports, and I want to see this device right here, USB serial device COM4. This is the Triggerscope. So it shows up as a COM port. That's a standard interface port that allows you to send text and decimal and hex strings back and forth on a USB connection, and the computer treats it like an older style serial line. So a lot of our microscopy devices use this type of communication method, and that's what we're using as well here. So note the port number COM4 on my system. On your system it'll be different, and that's okay. But if you have a lot of devices installed, you don't want to try uploading firmware or talking to other devices. In some cases, even opening up a device and talking to it with the wrong language can cause that device to get stuck, which will require sometimes a device restart. So just for a headache reduction factor, I'm going to eyeball which COM port my Triggerscope is on. Okay, so the next thing I'll do is I'll download the firmware. I did want to walk through this a little bit more specifically. So I'm going to go to the Micromanager Triggerscope MM firmware variant. This is hosted by Nico. And what I want to make sure of here is that I do not right-click and say Save Link As. In addition, what I do not want to do is try to download these files individually. Instead, the right way to get this software downloaded is to click the down button here and choose Download Zip. So once I do that, I'll get the zip file, and if I open that zip file, which I'll do here, it'll show the master repository. I can open that up, go to the source file, and this is the directory that I want. So I'm going to right-click and choose Copy. Then I'm going to walk over to my User Documents folder, choose the Arduino folder, and then right-click and paste into this folder. Now, I already have this software, so I'm not going to repaste it, but you want to end up where Documents Arduino, and then you have your files located there. Okay, so that's it. We've downloaded the firmware. If we continue along with the guide, you can see here I've called out that code button because it's pretty important, and we extract the firmware, and once it's pasted into the Arduino folder, we're going to run the Arduino app. So to do that, we can choose the Start button here, and I can either choose directly from the program list, or if I can't find it, I can just type in AR and get Arduino. All right, so this will open up. Now in this case I'm using this is a development version 6.13, but it's the same for any version you download. The first thing I'll want to do is open the INO file. So if you notice, there's the directory for the firmware, but if I open up that directory, there's a bunch of little files inside. I want to open the INO file. It's got the green Arduino icon there. So I'll open that, and that will by opening that file, it automatically includes these other files. Okay, the next thing I need to do is I need to tell the software that this software can support many different kinds of microcontrollers. So I need to tell the software what board type to compile for. And if I get this wrong, it'll throw errors. So I'm going to choose, and if we look at the guide here, we can see right here, we're going to choose board TNC41 under the board menu, and then TNC Arduino TNC41. So let's do that. So I'm going to go to Tools, and then Board. It's yelling at me about my libraries here. Try that again. There we go. TNC Arduino, and then I'll make sure that TNC41 is selected. Okay, with that done, the next thing I'm going to do is just double check I'm on the right COM port. So you can see in this example, we'll select our COM port, and I've used COM4 as my demo example here. So Tools, COM port. And it doesn't matter which one of these two you choose. It can be COM14C down here, or it can be this guy. It's the same thing. Okay, so the next thing to do is to try to compile, and we're going to do that using this checkbox here. So this tells the software, try to build up a complete firmware file, but don't upload it into the unit yet. So we'll try that. We'll hit verify. Okay, and it's trying to compile. And either it will throw an error or it'll tell us it's done. Okay, so it's done. Now you'll see in the Triggerscope 4, you'll get this window that'll pop up. We're going to talk about that in a minute. But it's done compiling, it seems happy. So that means that we're ready to compile. So as long as you're ready to compile, we'll proceed to that step, which is pushing this right arrow button here, which will upload the code. Now the little window that we saw earlier, we're going to keep an eye on that. And what we should see is that that window appears, it loads the firmware and resets the device. It's going to happen real quick. So we'll hit upload, and I'm going to keep an eye out for that window to appear. Oh, there it is. Okay. Erasing programming, reboot. Okay. It did all that, and we're finished. Here we get done uploading, and if I want to know for sure that the system is working, I can open up a serial monitor window here, and I do see the firmware, and it reports in this case the correct firmware version. Now Nico's firmware is really nice because as long as you're using new line commands, if you want to type things in, you can just send it a question mark and it'll tell you all the different commands that you can use in text. So that's kind of a nice getting started thing. If you want to know for sure that the firmware's on there, just send it a question mark and make sure you have new line selected, and you should see this. Okay, so with that done, we'll close down the Arduino IDE. And at this point, the firmware is loaded, should be operational, but the only way to really find out is to load up Micromanager and see what happens. So the next thing we're going to do is we'll load up Micromanager. I'm going to use Micromanager 2 Gamma. I'm going to open up a new demo, the standard MM2 demo config, if I can find it. Let's just pull up the root. Oh, let's see. Like maybe I don't even have the original config. So that's fine. What we'll do is we'll just for now load this as none. Alright, so we got a completely blank Micromanager version, and I'm going to go to Hardware Configuration Wizard. We'll create a new configuration, and I'm going to add in this case I'm going to add in a couple things just for us to test. So I'm going to add in a demo device, and this is just so I can have a fake camera. So we'll choose a demo camera and maybe a demo objective, and that'll probably be enough. That's fine. Okay, and then we're going to add in the Triggerscope. Now there's two versions. So there's the version that I originally made, the ARC version, which is under Triggerscope. But in this case, we're going to use the Triggerscope MM version. If you're using Micromanager, especially if you're using it for a standard setup where you're just driving lasers and LEDs and things like that, I recommend this setup because Nico's done a great job of integrating the driver. So we've got COM1, COM4, or using a TCP/IP. We don't want to do that. We want to choose COM4, as we noted earlier. I'm going to choose baud rate is going to be 115.2. And we can hit OK. And it'll either be happy or it won't. So if we get to this page, this means that Micromanager in the background talked to the Triggerscope talked back, everybody's happy. So what things do I want to connect? And this is where things get really interesting. Now, I'm going to choose a couple different options. I'm going to choose TTL 1 through 8. I'm going to choose DAC 1 and DAC 2. Now you might be asking, where's all the other TTL ports? They're all included in this 1 through 8 list. So this is a single byte value that gives us access to all 8 channels, and the implementation is really nice. So we'll cover that. The second thing I have is an option for the voltage range on the DAC lines. I'm going to choose 0 to 10 volt for both. If you're using a laser, you typically want to use a 0 to 5. You don't want to overdrive devices. So 0 to 5 volt should be sufficient for most lasers. And the last thing I'm going to do is I'm going to choose under the utilities menu, I'm going to choose a state device shutter. And this doesn't have many options, so we'll just hit next. Okay. Proceed through, give this a file name. Maybe this time we'll put this in Micromanager 2. And we'll call it, yeah, DemoTG. Why not? Okay. So at this point, the Triggerscope should be communicating with Micromanager. One of the ways I know that, first of all, down here on my screen, I'm going to show this webcam screen here. I've got on the top an oscilloscope, and then on the bottom is the Triggerscope. On the left side, you'll see a green LED. This LED indicates that my 12 volt power is on, and I do want that on pretty much all the time. So there's an on-off switch, and I've flipped that up for on, and I've got my ready light here. The ready light shows that the system is indeed communicating on the serial connection. So above that, I've got this oscilloscope. Now, there's a yellow line. I'll turn that on real quick. And what the yellow line shows me, it's kind of hard to see. I'm going to turn off the lights. That's a little better. So the yellow line shows me a 0 to 5 volt output of a TTL pulse. In this case, this is just 10 hertz, 10 cycles a second. You'll see down below the trigger LED is cycling back and forth. If I change my frequency here, I can, there we go. I can drop the frequency and we'll see that the LED flashes on and off. A little bit slower there. Okay, so we'll pause that for a minute. We're going to go to the device property browser and we're going to look at a couple other things. Now, on my second line, I think on this one, the second line is the DAC output, and then the third line is going to be TTL1 on the oscilloscope. I'll walk through those as I show this. Okay, so I've got a couple entries. I have TTL1 through 8 state, and then I've got individual TTL lines, and then I have a bunch of options for DAC. So let's cover TTL first. So this is an elegant implementation that Nico did. If I open up a calculator window, and I view this calculator as programming calculator, and I open up a bit value register, what Nico's done is he's assigned a bit structure, so these last 8 bits, to the on and off states of the TTL outputs in the Triggerscope. And what's really nice about this is that it's a very fast and repeatable way of delivering a hex value, which is just a very tight data-packed method of setting all your bits to 1 or 0, and therefore changing the states really quickly with minimal communication on the serial line. So a lot of users have gotten a bit confused by this if they're not kind of in the programming realm and aware of this stuff. So let me give you an example. If I choose this TTL state to 0, well, everything's off. But if I choose 1, TTL1 comes on. Okay, that's fine. But how about 2? Okay, 2 comes on. And how about 3? Okay, now 3, we would imagine TTL3 would turn on. That's each individual line down here. And we would imagine that TTL1 and 2 are off. So let's try to force it that way. Okay, so that's set the TTL8 state to 5. So what the heck is going on with this? So that's where these bit states come in. So a numeric value with in computer logic is a representation of an array of 8 bits. So if I choose the least Indian or little Indian bit, I get a value of 1 if I turn it on. If I choose 2, I get 3. That doesn't make sense. What about that? There's 2. So you can see that this is basically TTL1 to TTL2, TTL3, TTL4, 5, and then through 8. So if I want to activate just TTL8, that would be value 128 for this bit mask. So if I then go down here and I choose, we'll just turn all these guys off, and I'll type in 128 and hit enter. Notice that the slider value, TTL1 through 8 state, goes to 128, and the TTL8 line goes high. So that's the way the bit register system is made. It's a very elegant way of implementing states, but it does take some thinking in terms of how exactly to set things up. So if you want let's say line 1 and 4 to be turned on, the easiest way to deal with this is just to open up a calculator, set it to programmer mode, and click this little bit mask array here. And then let's choose, for instance, line 4 and line 1. Okay, so that's bit value 9. So if I come in here and I'll just enter in 9, I got 1 and 4. So that's basically the trick to assigning on and off values, is just to use this 1 through 8 state. That's the only thing you need. It'll support all the possible modes of on-off states that you want. You just have to set up what numbers mean what, and then code that into your wavelength setting or your channel setting when you're making groups and presets. Okay, so how would I use this in a group? So let's turn this off, and what I'll do is I'll make a new group, and I'm going to call this group channel. Now if I only choose one thing, all that's going to do is expose that slider or control to the group preset listing, and I don't really want to see that 128-bit thing. That's not really user accessible. So what I'm going to do is make sure I choose at least 2 things. In this case, I'll go down and choose my TTL 1 through 8 state here. And then maybe the second thing I'll do is just choose something random, like maybe the camera exposure or something like this. Maybe, how about binning? Why not? Okay. And for the preset name, we'll choose, Dappy. Okay, TTL 1 through 8 state will be 1 for channel 1 on. Decam binning can be 1, that's fine. Let's make a new preset, and it'll be, let's say, GFP. And in this case, GFP will be setting 2. Okay, so now if I switch to Dappy, TTL1 should go on. If I switch to GFP, TTL2 should go on. But if I switch to Dappy, I'm going to go turn on my trigger source right now. And if I look at Dappy, okay, Dappy in this case is this pink line down here. It's kind of hard to see, but it is high right now. If I choose GFP, the line drops to 0. So let's assume for a minute that I've got my Dappy selected. Well, Dappy's great. The line's high, fine. But the problem is, in this case, if this was a Dappy LED, the LED would be on and emitting even when my camera may not be active. And so this is not desirable, obviously, for our sample. We want to have the shutter, or I'm using my air quotes here, the system shutter, disable the LED unless the camera is operational. So the way I'm going to handle that is the device that I added, the state device. If I go to the device property browser and I choose the state device shutter to be TTL 1 through 8, instantly we see that line drops to low. And now if I go live, I'm going to set state device shutter is my active shutter, and I'm automatically going to use it. I'm going to go live here. And what I'm going to see is that that shutter goes high. If I stop the live, the shutter goes low. So what's happening here is effectively a mask. So Micromanager has built into it this control over the state device. So whatever your state is on your TTL output, that output will automatically be turned on when an expose is active and off when an expose is closed. So that's great. That's basically how you can gain shutter control over TTL output devices. Now the second thing to look at is the analog output. So we're going to go and grab the device property browser and simply grab DAC1, and we'll just adjust some values and look at what we get. So we're going to look at the screen down here. I apologize, it's small. But let's grab DAC1, and we're just going to take the slider and start to slide it up. And what we're going to see is that DAC value is raised. Slide it up some more because it goes to 10 volts. And sure enough, it continues to raise up. Okay, that's all well and good. The line works, but first of all, what are all these other controls? So the blanking is used in conjunction with an external trigger. So right now on my oscilloscope, I can see I have these raised and lowered voltage values. I can follow these values with my laser. So assume for a minute you had an AOTF and you only wanted laser emission when you knew your camera was truly in a readout or exposed state. So maybe here we have the expose goes high and then the expose goes low. So in that case, I only want to illuminate the specimen when I know the camera is collecting light. When it's not collecting light, I want to keep that specimen happy and I want to blank off that laser. So that's what blanking is. So if I turn blanking to on right now, I got to choose the appropriate DAC line. Here we go, blanking on. What I'm going to see is the shape of my output line is going to change from always on to now that output line is following the on state of the expose of the camera signal. So if I change the camera signal, we'll speed it up here. Let's go maybe 15 hertz. You can see that the blanking is active, and if I slide the voltage slider, the blanking follows the maximum voltage output set. So this is like a really simple way of activating a shutter, if you will. Many of the cameras that we use with Micromanager, Photometrics and or Hamamatsu, these cameras will not output a TTL state unless they're exposing, and if they are exposing, you're going to get an image. So in that case, there's not a condition where you don't want the laser on while exposing. So you could imagine another way to set this up would be, don't even worry about the shutter. Let's say we have two analog output lines, and in this case I'm only tracking line 1 on the oscilloscope, but I could set up another group. In this case we'll call it maybe a channel 2. Oh, I guess it wants a property. So what we're going to choose for this group is we're going to choose DAC1 volts, and we're going to choose DAC2 volts. And we'll choose DAC1 blanking, and choose DAC2 blanking. Okay. And for this one we'll call it rhodomine, and we'll make a second one. And maybe on this one we'll turn channel 3 to 0, and we'll turn blanking off. Channel 2 blanking will go on, and we'll call this one Texas Red. So now we've got two different channels, and blanking should be activated whichever channel we activate on the preset. So I'm going to choose preset 1. Let's go back and have that repopulate. There we go. So when I'm in the Texas Red setting, we can see in the oscilloscope no blanking occurs. When I choose the rhodomine setting, I get blanking, and it's set to the appropriate intensity value. And so in this case, if I'm using this TTL output, you can imagine if I turn my camera off in 3, 2, 1, camera goes off. Okay, and now I no longer have an output, which is why we're not getting updates on the oscilloscope. When I turn it back on, I'm going to get updates again. So this is another way of, I'm using air quotes, shuttering the output of the DACs for your microscope. And in this case, I don't even need the state device shutter. This can be set to none, or this can be set to off, because everything's handled directly in the Triggerscope from the TTL input. Now, physically what's happening here is I have a wire, and it's this wire here, and it runs to, in this case it's a function generator, but on a camera system it would be to your expose outline. And you will need to get typically a breakout cable that allows you to connect into your camera and do this. And finally, if your camera has inverted polarity, meaning some cameras, if their expose line is active will be low. So in this case, Nico's added in this option for blank on, and we can choose low or high. So if we choose, for instance here, we'll choose high, what we're going to see is, in our oscilloscope, is now we have inverted polarity. So now we are high when the output signal from the function generator, or the camera, is low. So regardless of the camera type you have, regardless of the line selection that you choose on the camera, we should have enough support here to take care of your needs for laser illumination, LED illumination, or whatever you're using in conjunction with blanking. Now, I'm not going to get into sequences, probably do that in another video, but you can set this up to interact with the high-speed sequence engine inside of Micromanager, and that's really where the power is realized in the Triggerscope for hardware device control. But if you're just setting up a basic system and you want to take images and do time-lapse and things like that, these setups should work for you. And if you have any trouble, feel free to reach out either on the forums, or you can contact us at ARC, and we're happy to help you out.